Welcome to Ethical Hacking Essentials. We are in Module 7. In Module 7, we're going to be looking at web application attacks and countermeasures. Web applications have become such an important part of everything we do that it's very important to understand how attacks occur and how to defend against them. With that, we're going to be looking at 8 different sections in this module. Number 1, we're going to understand web server concepts. How do web servers work? And then how do attacks occur? We're going to be looking at web server attack tools and countermeasures. Then we're going to move from web servers to web applications. We're going to be looking at web application architecture and the stack of vulnerability and threats and attacks to web applications and some of the tools that we can use as countermeasures for web applications. And then from web applications, we're going to move to a third topic that's part and parcel of this whole thing, because so many web applications that are running on web servers are attacked through injection attacks like SQL injection attacks. So we're going to talk about SQL injection attacks and tools and countermeasures. All right, it's going to be fun. Let's go to number 1. So in number 1, we're looking at web server attacks. So what are you doing right now? Oh, you're in a class. And where is this class? It's online, isn't it? It's being served through a web server. Now, every once in a while in this class, I will ask you to open up a tab and go to Google or DuckDuckGo. Where is Google or DuckDuckGo? Where is that page coming from? A web server, you say? Absolutely, it's coming from a web server. If I ask you to go look at RFC 1918 from the IETF, and you go look at that page with all that small print, where is that page coming from? You guessed it, a web server served out of a virtual machine or a container. Either way, the web server is serving the web app very often, and that is what we see day in and day out. A lot of organizations have their own web applications running on their own web servers, which really need to be protected. So let's get started talking about web server attacks. So let's talk about various web server attacks. A few things we need to think about when we are talking about web servers and really their functionality. So here's the web server. There's a web container. There are services. There is a data store for various applications that might be running associated with that web server. There are requests and response that are made through servlets on the web server to the web application server. And there is a static store for information that's usually on a hard drive SSD or on an attached service for a storage network attached storage server. But then on a phone or on a tablet or on a desktop or somewhere, there's a web client that makes the requests. HTTP request comes back. The web server checks with the servlet, makes a request to the application server, and the static data store and the application data store together, they put together a page, and the client downloads it and runs it. This is just a typical way web server operations work. And there are many different components. And when you think of a web server that runs many different web applications, remember, it's just a computer. For the most part, it's just a computer. And so it has folders and it has files, and out of those folders, and one of those folders, guess what? Inside one of those folders is a document store that has, for instance, the default HTML document that loads when you go to that URL, that universal resource locator record, like www.somewebsite.com, right? And so that document root is part of the server root that has configuration files, documents, executables, log files, etc. And there is an entire virtual document tree on the machine, on the disk, and so we want to make sure that we manage that if you're managing web servers. Then we may have a proxy that sits between the client and the web server that helps with some security, prevent IP blocking, help to maintain anonymity. And then we have virtual hosting. This is a technique that you'll find on most web servers where I can host multiple domains. So if I go to GoDaddy.com and I buy a domain called KevinKingDomain1.com, and I buy another one, KevinKingDomain2.com, and Kevin King Domain, I buy 16 domains, and I want to put out 16 websites on my web server, I can virtually host each of those domains and have a separate website and a separate storage and so on for the virtual document tree for all of those Kevin King domains that I just purchased at GoDaddy. So those are some of the components that you'll find in a web server. Now, here's one of the major issues. One of the major problems is way down here, we have security. We have a lot to think about right here at level 1. We have firewalls, intrusion detection systems, intrusion prevention system. We have host-based intrusion detection system and prevention system. We have wireless intrusion detection and prevention systems. We have a lot of stuff going on right down here at this level. But wait, there's more. We also have the level above that in stack 2. We have routers. In fact, there may be 15 or 16 routers in a medium-sized organization. There may be 50 to 60 switches in a medium-sized to larger organization, and each of them have VLANs and routing protocols and router security and VLAN security, and they may have redundant architectures, and they may have secure protocols, and they need to be hardened and so on, and more right here at stack 2. But wait, there's more, because at stack 3, we have Windows and Linux. And so we have Windows workstations running Windows 10, Windows 11, Windows servers, running Windows Server 2016, Server 2019, Server 2022, Linux. We have Ubuntu, we have SE Linux, we have Mac operating systems in one of our graphic design department with 20 people working on Macs, and each of those has to be hardened, looking for every service, every protocol that should and shouldn't be running, every application, updating every application, updating the firmware on the servers that have drive controllers and drive arrays, and it goes on and on. All of that is right here at the operating system stack. But wait, there's more. You might have MySQL or Microsoft SQL Server, SQL Server, Oracle, and other databases serving various functions. Those have to be updated, maintained, secured. You might want to use data masking on your database. You might want to use encryption on your database transactions. You have DBAs and DBOs that administer and own the database, and a lot of work to be done at the database level. And then finally, right up here at stack 5, there we have our web server that needs to be secured, that this module is going to be talking about, Apache, Nginx, Microsoft IIS. And guess what? All there has to be in all of these stacks up to stack 5 is one flaw, one hole in the security, and an attacker has a foothold on your system. But yet, you, as the network defender, the ethical hacker, have to lock down tens of thousands of combinations of protocols, ports, programs, applications, devices, etc. You have to lock it all down and keep track of it and make sure that it is secure. So that is the security issue. It is the complexity of the different stacks put together as a whole that really gives you a lot of work to do. And that's why at the beginning of this class, if I didn't say it, we need you. We need you working in the security field to help keep all these levels secure and trap and prosecute and stop attacks. So the impact of web attacks: accounts can be compromised. Websites can be defaced. Root access to the server can be obtained, exposing other applications and the operating system of the server. Data can be tampered with and stolen causing not just the attack on the website, but they can bounce from that web server into the interior of the network, into the DMZ, into the data center, wreaking havoc wherever the attacker goes. And if they have enough of an attack, a big enough attack, then there can be reputational damage to the company. Did you hear about XYZ Corp? Yeah, they were attacked. I can't believe it. I don't know if I should buy anything from them again. So lots of impact for web server attacks. Why are they compromised? There are many reasons. Let's look at some of them. Number one is there are improper file and directory permissions. So let's say that I ask you tomorrow, I say, you know what I'd like you to do is I need you to build me a web server and so I can build a website. And you might say to me, but I've really never worked with a web server before. I'm not sure what to do. And I might tell you, hey, you know what? Just go to YouTube and find yourself a 15-minute video on Apache. All right, let's see if we can get done by tomorrow. Yeah, tomorrow morning. And so you watch a 15-minute video on Apache. You discover, oh, Apache is a web server. Oh, these are some of the commands that you use to install the web services. And in another hour, you have a web server up and running. Well, now, maybe tomorrow, for instance, I upload my website. And my website starts running. It's posted on the internet for all to see. However, there were some configuration setting problems. There were default settings. Nobody changed the file permissions. Why? Because maybe you didn't know about it. Maybe this is your first web server ever. Who knew that you're supposed to secure files in a certain way? Maybe on the web server, there are still services running. Do you know that on a lot of these web servers and a lot of databases, there is a example site? It's like a test example site just to show that the web services are running. Maybe you left the sample site there. So those are some of the issues that could happen. And maybe there's no integrated authentication with back-end systems like Active Directory or something. Maybe it's a standalone web server. Maybe there's a default account to Apache or whatever web server you're using. And so overall, a web server can be misconfigured. Right now, were you to ask me the same thing? Hey, Kevin, can you do me a favor? Can you set up a web server for me? I know it's kind of late, but I really need to post a website tonight. I probably wouldn't do that good of a job. I would have to come back later and run tools to look for vulnerabilities and then get guidance as to how I should lock it down, right? It's not something you know unless you do this for a living. So there could be conflicts with business cases. There could be maybe a lack of security policy. For instance, if an organization had a strong security policy and they wanted me to set up their web server, guess what else they would have? They would have a standard operating procedure for setting up web services for the organization, and I could follow the procedures and lock it down right out of the box and just go page by page and set up the web server and make it super secure because there was a procedure, because there was a policy. So that becomes something very important too. I would love it if I could set up a web server according to a policy with a standard procedure that I could follow step by step. It would make me feel confident that I'm doing a pretty good job setting up this web server. So each one of these are possible reasons why web servers are compromised. And there are many different types of attacks too. Let's talk about attacking web servers. One of the attacks is a DNS server hijacking attack. And in this case, what's going to happen is the attacker is going to compromise DNS servers, change their settings. With that done, when a user has a FQDN, fully qualified domain name, or a website URL that contains the FQDN and so on, request the DNS server, hey, DNS server, can you give me the IP address for kevinkingsnewwebsite.com? And it'll send that to the web server. And the DNS server checks its mapping for that. It checks its database, sends it back to the user. But oh no, that's not real. That's been compromised by, this person, they're wearing a hoodie. I should have known. They're wearing a hoodie. And it's been compromised. and instead I get sent to the fake website. You know what? These fake websites, they look very real until you get too deep, and then they start to fade from the reality, but they are surely good enough to collect credentials. So that is one. DNS server hijacking is one web attack. Another web server attack is a DNS amplification, taking advantage of how DNS servers can do iterative queries where they recurse through the entire DNS hierarchy. And what we do as the attacker is redirect them to perform an amplification attack. So let's look and see how that works. Number one, the user needs the IP address for a URL or an FQDN, fully qualified domain name. And it says, hey, what's the IP address to this FQDN, certifiedhacker.com? Please reply to my IP address, is what the user's PC is effectively saying. Sends that over to the user's primary DNS server. And with this DNS server, a recursion is allowed, which means that the server is allowed to make what's called an iterative query. See, this is a recursive query right here, where the user says, hey, give me an answer. That's a recursive query. But an iterative query allows the DNS server to rebuild the FQDN from the TLDs on up. What in the world does that mean? Rebuild the FQDN from the TLDs on up. So TLD is a top-level domain, like com. So for instance, what will happen is it's never heard of this, so it will contact one of the root servers of the internet. There are 13 root servers that are spread all over the world, many different versions of each of those servers. And so what it'll ask is one of the root servers, where can I find the address? And it'll ask for a .com namespace that's nearby that might have the address. And then from there, it finds another DNS server that is responsible for the .com, that's a TLD, top-level domain, .net, top-level domain, .mil, top-level domain, .cc, .gov, or whatever. Those are top-level domains. So it gets that TLD information, and then it says, hey, do you have the IP address to Certified Hacker in your database? And the .com server says, yes, I certainly do have the IP address for certifiedhacker.com. So that entire escapade through all the levels of the FQDN of the name that needed to be resolved from the TLD all the way up, that is what we call an iterative lookup. And at the end of the recursion, the DNS server provides an answer. Now, this DNS server, if it didn't have the ability to do recursion, it could have just found another DNS server and say, hey, I can't look that up. Hey, a secondary DNS server, do you have the answer? And if that had happened, then it would have been a non-authoritative answer provided to this user. But in this case, it did all the work, so it's authoritative. But here's the problem. Because of the ability of this DNS server to look at the entire domain tree and find the IP address of one of these sites, because recursion is turned on, there is an attack that can happen. So here's what happens. So the attacker, what they're going to do is use a compromised PC that has a spoofed IP address. In the end, what they're going to end up doing is amplifying a distributed denial of service attack against their target, against the PC. So they're going to send a signal and say, activate bots. And the bots are going to all turn on and get activated inside all of the PCs that people are owning and using all across the country and other places in the world. And here is how it works. The botnets are going to say, what is the IP address for this? And they're going to say, reply. Don't reply to the botnet computer. No. Reply to the computer that we are attacking. So can you imagine it's going through all the recursion, grabbing all the IP address information, and then when the DNS server finally replies, what it does is it replies using thousands of requests to a single address, amplifying the attack, right? So that's because on this DNS server, recursion is allowed, and this server is not authoritative for certifiedhacker.com, and as part of all that, it sends the attack to one device. Other types of attacks, and this is one I've used very successfully before in capture the flag contests and so on, and this is a directory traversal attack. So when you look at where a web server is, it's just a file. It's just a server that has folders and files in it, and the website or the web app itself is just stored in folders on a drive somewhere. And so if my web information, let's say it's in webroot, and I type in .. it takes me up to inetpub. I type in .. again, it takes me up to the C drive. So I can do .. combinations and a trial and error method. In fact, I can even, like if I'm on a Linux server, I can type in .. /etc.passwd and get into some password information and try this over and over again until I get to where I want to go. And then from there, I can read information, execute code, stuff like that, if it's possible. The next attack is website defacement. Many websites get defaced, and what they do is they just alter the appearance. They can say, "You've been pwned, you're hacked," or they could put, all kinds of curse words or really gnarly pictures on the website and stuff like that. Or maybe even just put a bunch of propaganda on the site, political propaganda, religious propaganda, propaganda on the site. That's defacing the website. The next type of attack is really something that happens because the person who's working with the web server misconfigures it. It's a weak configuration of the web server. It's just not configured properly. Here are some configuration problems. Let's look over here. So remote administration on the right side, we see allows somebody to get into the web server and remotely administer it. If that's not secure, if information leaks from that connection, then that can be a big issue, allowing an attacker to remotely gain access to the web server. Unnecessary enabled services. So you may have a web server that's running on a device that has many other things that it's doing that are unnecessary for web services. Is Microsoft Office necessary to run a web server? No. Is Adobe PDF Reader necessary to run a web server? Is some music player or other type of software? These are not necessary for a web server. What we want for the web server is only necessary files. And we can have certificate problems that are misconfigured. They could be old versions, stuff like that, that the attacker can look at the handshake for SSL and determine that it's old and start an attack. Here's another problem too. Let's say that I go to a web server. There's a website on the web server, and I open up the website and there's an error, and it says error 501, and it gives me all kinds of information. Error 505 or 404, and it gives me all kinds of information. Attackers use that information to do more attacks. And so what you need is generic errors. Maybe you've seen this before. You go to a website and it says, "Oops, an error occurred," and that's all it says, right? That hides that error reporting information from the attacker, and so they can't use it for further attacks. Another one is anonymous or default users or anonymous or default passwords, which can be left over from a bad install where you forget to remove some of the defaults. Another one is sample configuration files and script files. Like I was saying, a lot of web servers come with a default website to kind of demonstrate what the web server looks and show you that the web service is actually running. Same with scripts and so on. And we need to make sure that if they're not needed, they're removed. And really no sample is actually needed for a production web server. Also, we have other misconfigurations. Here are a couple of examples And here's one where anyone can view the server status page that has detailed information about the web server. Look at that. You can see, well, you can't see much, but this is the httpd.conf file on an Apache server, and you can dump all kinds of information about the web server using that. Here's another example. This one gives you TMI, too much information, in this php.ini file, where the attacker can go look and see information on errors, syslog entries, and other information that are because of verbose error messages. That's another issue. In terms of web server attacks, another one that's pretty bad is an HTTP response splitting attack. With this one, what happens is there is a header that's added to the response data. And so you could use something like Burp Suite and edit the response data, adding in a header, and that splits the response data into two fields so that the server splits the response into two responses. So we get two separate responses. And so the attacker controls the first response. And what they do with that is they redirect the user to a malicious website rather than where they were going to go. This is a response splitting attack that happens. In this case, it's Jason the hacker that's sending the user to the improper website. Another one is web cache poisoning. Web cache poisoning. Whenever you hear the term poisoning, that means that we are taking legitimate entries into some type of cache and we are changing them. So where do we have caching? We have ARP caches. Talked about that a little bit, where ARP entries are cached, and you can do ARP-A and look at them. We have DNS caches, where DNS lookups are cached, and you can use NS lookup, for instance, on Microsoft systems to look at the DNS cache. And we also have web cache. What your system does is takes the website that you looked at, and in reality, guess what you did? You downloaded that website. And since you downloaded the website, it's cached on your computer. But what an attacker can do is poison the web cache. And in this case, what they're going to do is use a multi-step process to swap out the cache content. And so if my web cache has been poisoned, swapped out, instead of true and secure content, when I go back to that URL, I'll be redirected to a fake page where all kinds of bad stuff can happen. So in this case, this attacker is flushing out my actual cache, putting in their own information with a specially crafted request that will take me where I don't want to go. That is a web cache poisoning attack. Here's another one called a SSH brute force attack. Whenever you hear the term brute force, what you do is you're going to try every possible combination until you find a combination that will break or attack or crack whatever it is you're attacking. That's what a brute force is. And so what we're doing in this case is we have SSH. You think, wow, SSH is nice. It's secure. It makes everything encrypted. But if you're using the wrong version, or if it's implemented improperly, it can make your network not secure. And so what they do is they brute force the login credentials of a bad version or install of SSH, and they get unauthorized access to the SSH tunnel. And so meanwhile, while I think, wow, everything is secure, at HTTPS, realize that the attacker is able to run exploit, transmit malware, and do other types of pretty bad stuff because SSH has been compromised in a brute force attack. Another type of attack is a web server password cracking attack. So what happens is there's a weakness that allows the web server to attack the passwords, an attacker to attack the passwords of a web server. And so some of the most common passwords that somebody might find in a web server are simple: root, password, administrator, admin, and even demo or test. And can you imagine QWERTY, guest, what's a pet name? Fido, Dogface, I don't know, all kinds of pet names or whatever it is. Look up the top 1,000 passwords, and those might be some common passwords that might be found in a web server. And so what the attacker does is targets things like SMTP services, web servers, like we saw before, SSH tunnels, web authentication forms, cracking those. And if there's an FTP server, those can be very crackable, and they can use many different ways to get these passwords. Sometimes it's impossible to grab the password from the web service stack, so you just ask somebody, social engineering, or do some spoofing or phishing, or maybe even upload some malware like a virus or whatever. Still doesn't work? Well, maybe we can do some wiretapping and listen in on what people are saying, or sneak into that company carrying a ladder with a uniform on and make it all the way back to the system administrator's workstation and plant a keylogger and just wait till I collect all the passwords from the keylogger. There's so many different ways that an attacker can crack a web server password. So one of the ways that they can do that, this is going to be an attack that we're going to use a dictionary attack, right? And so this is actually THC Hydra. Let's have a look in and see what this hoodie-clad attacker is doing. What they're doing is in Parrot Security Linux, they're typing in the term Hydra. Oh, no, this is not the one in World War II with the guy with the red face and so on. This is a whole different Hydra. This is THC Hydra, and we do a -L for list. And then we do a /ROO, and we hit tab. In your lab, when you're doing this in your lab, you do that /, type ROO, and then hit your tab key, and it fills it into you for the next slash. And then you type in W, tab, and it fills in word list / for you. You type in U, capital U. Remember, you do capital W for word list. Remember, Linux is case sensitive. And if you use that tab key, it'll fill in each leg of this path for you. And then you put a space there, and then a --P for passwords. You put a space there, type in /ROO, and then hit tab. It fills it into the next slash. And then you put a capital W tab, and it fills that in. Capital PA tab, and it fills that in. And then, so now what we've done is we have a list of usernames. And we have a list of passwords. And then we put a space in. And then we have the target of the attack. We're going to attack an FTP server. The FTP : / to give it the 10.10.10.10 IP address, hit enter, and then listen to the music play as the hacking commences using that word list. And then, oh, we found one. Look at Apple is one of the passwords. Username Martin. Oh, wait, there's two more. Jason is another username. Password Cordy. Oh, look at that. Sheila is yet another one with a password of test. So in the real world, it's not so easy as the demo you have from your lab. Like for instance, there was a capture the flag contest, and I needed a password list. And there are so many word lists out there that are so huge that I finally found a username and a password list. And it was 84,000 something, round up to 85,000 entries. And it ran for a day and a half, and I got 0 hits on the username or the password. So in the real world, it's not always as easy, but in your lab, we want to make sure you're successful and you know how the tools are used and how they work. And so we help you out by giving you usernames.txt and giving you passwords.txt with nice, simple stuff to crack, like Apple, QWERTY, and tests. Another type of web attack is a server-side request forgery attack. One of the things you want to keep in mind with the word forgery, indicates, foretells the fact that in this attack, there was a login, all right? So what happens with a request forgery is there's a public web server that gets a crafted request from the attacker. What happens with the user, which you don't see on this page right now, but the user logs in using some type of credential. Either way, the web server sends a request on behalf of the user, and then data gets responded by the web server. But what happens in the end is if the attack is successful, they can do all kinds of activities on this network, on the server, port scanning, IP address discovery, reading files, etc. So they have a public web server. They send crafted requests to that backend server, and using SSRF, they are breaking in to that service. Another tool, and this says web server attack tool, but Metasploit is the all-around hacking suite of tools. It exploits everything. If you can think of something that could be hacked on a computer system, Metasploit is useful for that. So this is, I could teach a 2-week-long class for 10 hours a day on Metasploit with labs. It's just a huge environment. And so you can do web servers and other vulnerabilities. It's an amazingly large tool. There are a lot of other tools that you can use. We saw THC Hydra on there, Canvas, Hulk, MPAC, WAF, W3AF. So many different attack tools. Remember though, Metasploit is huge and extremely powerful. All right, let's look at some web server attack countermeasures. What? You say you don't want your web server attacked. Well, let's see what we can do to stop it from happening. Well, a few things to think about. And as we talk about web servers and applications and SQL servers and SQL implementations, realize that a lot of these countermeasures are not things that, let's say I'm a user and I go to somewebsite.com and like, oh man, I don't want this website to be vulnerable. What can I do to make this website less vulnerable? The answer is nothing. Really, it's not me as a user that's responsible for that. I need to actually have the developer, the administrators and engineers fix websites, web apps, and SQL servers, right? So I just want to warn you that some of the things that are going to be in these countermeasure lists are not things that you or I can easily adjust. These are things that as a network defender, when you are in a meeting with your developer for your website and your web app, you'll ask these questions. Well, hey, I sent an email to you, Mr. Web developer, and I just need to make sure, I want to check a few things. Have we applied restricted ACLs and blocked remote registry administration? And like, oh yeah, I have a tool for that. It's great. No problem with that. And you say, well, have we secured the SAM, or is it a standalone server? And your web guy will say, oh no, actually we don't have to worry about it. It's not standalone, and I'm not using SAM. Okay, good. Well, have you removed all necessary file shares and any default accounts permissions? Like, oh yeah, I always do that. That's a standard for us. What about your NTFS permissions? Oh yeah, what we do is we lock down every folder. So this is something that the web team is going to have to work on in terms of permissions and partitions. ISAPI filters, the ISAPI is the application programming interface for Microsoft web servers, and there are these filters included that are part of the web server when you install it. They're default stuff, and a lot of them get used by developers, but some of them don't. And if they're not, if they're unnecessary, you need to remove them, right? So removing any script mappings. If I'm somebody who visits a website, I have no method for removing IIS script mappings. This is something that the web team needs to know about. So if you're on that security team and you need to verify that your web server is as secure as it can be made, there are some tools. There's an app for that with Fortify Web Inspect. It automatically, dynamically tests your web servers, Acunetics Web Vulnerability Scanner, Retina Host Security Scanner, NetIQ, Saint, Sophos. There are a lot of tools out there that you can use to help you prove that your web server is as secure as possible. Let's now have a little talk about web applications. We use web applications all the time for so many purposes. It's important to understand architecture and the vulnerability stack for web applications. So let's have a look at that. And for web applications, it's the interface between the web server, the information, the backend database, and the user. And hopefully the developers have used security policies. If they haven't, or there are poor policies, they're going to have vulnerabilities to attacks like cross-site scripting and SQL injection and session hijacking and many others. So we need to make sure we're ready for that. This is just a look at how web applications work. Now, for a website or a web app, it's usually implemented on what we call an N-tier architecture, which we'll look at in just a moment. But let's just look and see what happens when this user goes to a website. Now, when we use the term go to a website, in actuality, we are either typing in the URL or clicking on a link, and we are making a request to the web server for us to download the website. So whether it's on your phone, whether it's on your tablet, or whether it is on your PC, you are downloading the website. And it really depends on some variables like how much storage you have and so on. But you're downloading that website. Another thing that I want you to have a look at, especially for hacking web applications, before we talk about how it works in specific, is this right over here. See right on the top of the screen, we have the URL. Let's talk about what this URL means. A lot of people don't think about what a URL means. So on the far left side, what we have is the protocol. We're saying, what protocol do I use to access the resource? So the protocol in this case is HTTP. There are many other protocols that can be used to access resources. Not all of them, though, would be web resources. Like HTTP and HTTPS are web resources, but if I put FTP, that's not web, right? It doesn't have markup language and tags and so on. So HTTP is the protocol that I want to use. All right, so if I'm using that protocol, where am I getting the resource? All right, so the resource is on the top level domain of com and a subdomain of certified hacker. So that secondary level domain or subdomain is one that you or I could buy. So for instance, I could go to GoDaddy right now or domains.com and buy the domain Kevin King bought this domain.com. I know that that domain has not been taken yet. And I can use that as part of the domain. Now, as you notice, we stopped there, just certifiedhacker.com. Now, in this case, since a document was not specified after the slash, there wasn't anything that said index.html or document.htm or anything like that. So no document is specified. So what happens is the web server will serve up the default document in that document folder. And so the default document is often like an index.html. All right, so another very important aspect of this is the next part of this URL, that question mark. That question mark is the dividing line between the protocol that we're going to be using and the location of the document that's going to be served according to that protocol, right? We've located the document, we are able to serve it up, and then to the right of that question mark, we have what are called parameters. We have an ID, we have whether it's printable or not, right? So one of the attacks is where you can take those parameters, the 6329 or the Y for print, and modify it. So I can modify the parameter from ID 6329 to 6330. And let's say that the print had been set to N, and I could set the print to Y. It might take me to a completely different person's information and allow me to print it. That's called parameter tampering, and all that takes place after the question mark. Before the question mark is document location and protocol. After the question mark are parameters that, when you hit enter, are sent back to the web server for processing, right? So remember, everything's on your local system, but when you hit enter, it gets sent through the internet, through any firewalls, to the web server. The web server may then contact a web application server, and that web application server may say, hey, database server, there is an ID of 6329 that's specified. Database server, can you please look that up? The database server says, okay, I have a query. The query is select everything, select star, from a table. What's the table called? News. All right, here's the news table where ID equals 6329. All right, here's the ID. What do I find there? I find tech and CNN. All right, let's feed that information back. There you go, web application server. This is what I found for ID 6329er. All right, web application server, let's create a page to send to the user and squirt that page over to the user through the firewall all the way around the routers of the internet, little BGP action there, and boom, the page gets downloaded. From the perspective of the web server, it's uploaded, but from the perspective of the user, it's downloaded, and it appears with the appropriate information. So like I was saying, a web app is usually an N-tier application. N meaning as many numbers, right? So this is a 3-tier application. Lower tier, tier number 3, is the database. Tier number 2 is the business layer, and tier number 1 is the web layer. In tier number 1 is where the web pages are created or used to upload to a browser. Tier number 2 is where business logic and calculations take place. And then tier number 3 is where you have your database, where you have a Microsoft SQL Server, Oracle database server, and others. So just to give you a quick example, I always use this example because it's very simple to illustrate. But let's say that I'm on a browser. I type in www.myreallycoolbank.com, and I go to my bank, log in. A page is sent to me with all the basics for somebody who is authenticated to the bank with specifics for my account. So in my page, I click on transfer. So when I click on transfer, it sends a request back to the web server, and it finds a page that has transfer information on it, and then it sends that back to my device. I download that page into my device. Now in the transfer page, there's a window for checking or savings. So I put $100 in the checking, and I tell it to transfer it to savings. So once I hit that button, then that information is submitted back to the web server. And now we go to the logic layer, the business layer, where somebody wrote Java or C# or Ruby or PHP or Python or all of these to get my business logic running. And then the business logic will say, okay, let's make sure that the Kevin King login is secure and actually has a savings account. All right, let's check database. Savings account, yes, no, yes. All right, does he have a checking account? Checking account, yes, no, yes. All right, good. Is there $100 available? $100 available, yes, no. Yes, there's $100 available. Okay, is there a place to put the $100? Yes, there is. It does all these kind of checkings in the background. And then it says, all right, database, decrement checking by $100 and increment savings by $100, and then give me your results. And it does that, and then it creates a new page, and then that page is sent to my browser, and it says, congratulations, you have transferred $100 from checking to saving. Is there any other thing you want to do? So that's what an N-tier application looks like, with the business logic and the web services and the database layer at the bottom. All right, it's good to know how some of these things work. Now let's look at some web services. Now, beyond just the tiered web delivery system, there are some more complicated services and applications that are deployed over the internet. Remember, we're not just talking about web pages. We're talking about complicated applications with protocols like SOAP and WSDL, UDDI, REST, etc. And what do? They help with service delivery to find and publish and bind requests to service providers to make sure that those requests get fulfilled. And there are descriptions of all the services available to web servers available in a service registry. And I wish we had time to go into some of these services. These are things that you learn a lot about when you are doing web application programming. We get to talk a little bit about it, though, looking at some of the top level definitions for SOAP and REST in particular. SOAP is based on XML. If you've never seen XML, right now, go to a search window in DuckDuckGo or Google and type in XML document. And then go to images, and you'll see how XML looks. It's a markup language. It's actually made to be fast and machine readable, but it's also pretty human readable too. You can see that if you go to images and look at XML documents. But what this does is it transfers data between the service provider and a requester. So you can create all these very quick SOAP requests in moving data between those two aspects of your web application. There's also the idea of RESTful web services, and this is just basically a set of constraints underlying the way HTTP is implemented to help improve performance. And there's literally days worth of information to talk about each of these, and there are so many different versions and then replacements for these, but this is not the class for that. If you want to know that, go into a web application programming class. All right, so with web applications, it was bad enough with web servers. Look right over here, web servers, all the way at layer 5. But with web applications, not only do we have third-party components that we purchase commercially or that we use and implement through open source, but we have the custom applications written with potential business flaws and potential technical vulnerabilities. Look at all of these stacks that we have to protect in order to keep our web applications safe. So there's a lot to think about when you're defending web applications. Next, we want to look at some of the threats and attacks that can be sustained by web applications. This is the OWASP Top 10 Security Risks for 2017, and we're going to look at some of these. So let's just have an overview. Injection, where you take a web form or URL and you put stuff into the reply that shouldn't be there. Broken authentication, sensitive data exposure, XML, external entity or XXE, broken access control, security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerabilities, and lastly is insufficient logging and monitoring. So these top 10 security risks, we need to have a look at them. Number 1, injection. With injection, what happens is the attacker takes advantage of the fact that the application will allow untrusted data to be sent into the application and interpreted and executed as part of the command or executed as part of the query. And so what they do is take advantage of these injection flaws, and they put in malicious queries through structured query language, or make commands, or even through LDAP, the Lightweight Directory Access Protocol, which is used for directory services like Active Directory. So another one would be broken authentication. With broken authentication, you know how we were talking about man-in-the-middle attacks and so on, how you can take advantage of session management issues. Well, with broken authentication, you can do that. Vulnerabilities in authentication also. If you look here, this is very similar to a man-in-the-middle attack where we're sniffing the session network traffic, and then we are getting session IDs, and we're using those to conduct malicious attacks. Over here, we have password exploitation, where we go to that web app, and we may find for instance, a password database associated with that web app. And if they're encrypted or not encrypted, we can use tools and techniques to exploit those passwords. There's also timeouts with web applications, web servers, and all the instrumentation and software. Sometimes the timeouts give the attacker the advantage. For instance, there's an application and the timeouts aren't set properly. So the user clicks close on the browser, but their information, like cookies or session information, is still valid. So somebody who has access to that can exploit that, escalate privilege, do all kinds of damage. Another one is sensitive data exposure. So for instance, what I can do as an attacker, since I have weakly protected data like credit card numbers or whatever, go to the code and just open it up and look at it. And there might be plain text information in the code right there for me to read. Right? With secure code, you're going to encode all that sensitive information so it's not so easy to read. And so sensitive data exposure is one that we can easily avoid by making secure code. The next one we have is XML external entity. So inside a web app, there could be a lot of XML going on. And an XML external entity is a type of SSRF, which is a server-side request forgery attack. And what's the problem? XML is misconfigured. So there's an XML parser, and what happens is the XML parser should only allow specific entities within the web services area to be able to do communications. But in the case of XML external entity, an external entity like you or me who is attacking or hacking the resource can send in a request. And when we send in the request, it's malicious. And that malicious request allows an answer to be sent. This response is TMI. What does the response TMI mean? Too much information. So as you can see here, it says that this web server is running Ubuntu. We don't want an attacker to know that. Look at the version 1804. We don't want an attacker to know that. And just information about that web server, about that web application, we really don't want an attacker to know that. So we want to protect against XXCs. The next one we look at is broken access control. Broken access control, what will happen is the attacker will already have identified a flaw in access control that allows them to bypass authentication to compromise the network. And so rather than getting denied, you have no access to this, the attacker will actually get root or administrative privileges, allowing them to create, update, delete, do whatever they want to wreak havoc in that application. Then we go to security misconfiguration. And for instance, there could be unvalidated inputs. Let's say you have a form. The form has first name and last name and other things you need to fill in. But what if the form allows 255 characters for the first or the last name? What if the form allows you to use any character you want? I do not know a lot of people, let me look on my keyboard, that have $, ampersand, star, and other things in their name. Do you know people with that in their name? I don't either. So what we want to do is validate everything that gets put into there. So instead of 255 characters in the name fields, we only allow 20 characters or something like that, maybe a little bit more. Instead of allowing every single possible combination, maybe dashes and hyphens, right, for like O'Reilly and stuff like that. So, and then if anybody puts in any characters, whether it's Kevin or O'Reilly or Bob or Francesca, and they hit enter on the form for the first name and the last name, and for every field, we validate. We look for things like SQL injection, and we look for LDAP injection, and we look for people who are trying to hack the form. So we validate all the inputs into the form. The next thing we have is parameter tampering, where we can manipulate parameters that are exchanged between the client and the web server. Remember I was telling you about that URL, and remember the question mark. And to the right of that question mark are the parameters. With parameter tampering, those parameters can be manipulated. And when those parameters are manipulated and you hit enter, it sends that information into the web server and it's processed, and that can cause issues. One type of parameter tampering attack can change the price that's in the URL from $1,000 to $1. You hit enter, and then you go to your box where you've purchased the device, and they say, congratulations, you've purchased this device for $1, and it will be delivered by September or whatever. right? So that's parameter or form tampering. Improper error handling is when there's TMI, too much information, that's being released in the error message, allowing the attacker to identify even more vulnerabilities and launch more attacks. And there could be weak algorithms that are used at the transport layer that allow the attacker to get extra information to use in other attacks, or actually attack the transport layer of security. One of the most, popular types of attacks that we see is cross-site scripting. So with some of the web scanners that we've talked about before, you can scan a website and find a website that's vulnerable to cross-site scripting. When an attacker finds a website that's vulnerable to cross-site scripting, they can upload code to that website, putting malicious scripts. And then, instead of a normal response when a user visits that website, they will instead get the code. So in this case, there's a little pop-up with an OK button, and it's natural for someone to want to click the OK button. When you do, you run that code, and whatever it is that is in that script that the attacker has, the target of the attack, well, it's kind of random people in some cases, will be served that code, redirected, hacked, or whatever it is with that exploit code. So that is cross-site scripting. Often cross-site scripting attacks won't be from random visitors to web pages, but the attacker will export the cross-site scripting attack by putting together phishing emails with links to the compromised page in that server. Another one is insecure deserialization. And no, it has nothing to do with good taste in breakfast cereal. This is a different type of serialization. As you can see, it's even spelled differently. What deserialization is if you look at, let's say, a web form that somebody's filling in with a name and age and all that kind of stuff, they put that information in. That information needs to be put into a form that can be transmitted across the wire and that's readable to other computer systems. And when it gets where it's going, it's read and deserialized into a database, for instance. But in the case of insecure deserialization, no process, no procedure is protecting this serialized data. So the attacker intercepts the serialized data and puts their own attack in it, allowing them to take down an unsuspecting user. So when you build a web application or a big website, it's not just a bunch of HTML. There are many different components that go into making that site. So like for instance, I was just talking about a web form. If you're not that good at creating web forms, you can go get a component that does web forms and just use it for your web forms. You can get components for sales on the website, components that generate and make useful all kinds of procedures and items in a website. These components, though, can have vulnerabilities that are already well known, so that if somebody scans your web server, your website, and they find that component, they can go to the Google hacking database and get step-by-step instructions in some cases to hacking your website. So make sure you scan all the components of your web application, of your web server, to make sure that those components don't already have known problems. Also, there's insufficient logging and monitoring. It takes an average of 208 days for an organization to realize that they have been attacked. I was talking about that when we were talking about APTs. And so an attacker that has a resource that is not logged, not monitored, they can spend all the time they want. They can spend 208 days. They can spend 2,000 days hacking away at the resources until they finally figure out a way in. And then finally, when you look and see what happened, you have no idea, how did someone just now hack into this resource? Oh, they've been working on it for a year and a half. But nobody knew because you had insufficient logging, insufficient monitoring. So it's very important to log and monitor every single resource in your entire enterprise. Now, let's talk about some tools for attacking. So with all this web attacking and dangers to websites and dangers to web applications, you might be asking yourself right now, how can I hack websites? Well, one of the major tools to hack websites, and it's actually very fun to use, is Burp Suite. Burp Suite, it supports everything in the application hacking, application testing process. Both of those, right? Hacking, testing, same thing, different perspective. You can map it out. You can analyze it, the attack surface, and then you can use it to find all kinds of vulnerabilities and weaknesses when you're working with a website. This is a very good tool. This is one of the tools that I would suggest learning, getting to know and understand how to use Burp Suite. Another tool that is very good for testing web applications is OWASP Zap. Very nice tool. It's a Z. Zap stands for Z Attack Proxy. Allows you to find security vulnerabilities and use those to hack a website. And then the all-around mega tool used for every type of hacking you can imagine is Metasploit. There's good old Nikto. What I like doing with Nikto is doing the initial scan, finding pages of a site that are vulnerable, and then using other tools to make use of those vulnerabilities. Sniper, Wisp, and other tools can help you with web application attacks. All right, so now let's say that you've used Burp Suite and OWASP Zap to attack websites for your organization. You've been asked to do so. You found vulnerabilities, and oh my goodness, you need to block web application attacks. So let's look at some countermeasures that can be used. And again, in this section, remember, a lot of these are targeted at the web application developers, the database administrators and owners, and the web server administrators. So that's what we're going to be targeting at. So a few things to think about for SQL Server injection attacks. Limit the length of user input. So like I said, this is not something that I can do if I go download a website and I'm looking at the website and I realize, oh, this website is hackable. I think I will limit the length of user input and use custom error messages. That's not up to me. That's up to the developer. So you're sitting in a meeting and you tell the web developer, I sent you an email. There are a few things that I put in there that I stole from the class I took last month. And those are, do we have limit length on user input? And the developer will say, yeah, we only allow, and they'll tell you about it. Do we use custom error messages? And the guy will laugh and say, yeah, they all say there was an error. All right, good, I like it. And so you go down this in terms of input validation and escaping dangerous characters and language-specific libraries and domain validation and LDAP filters and validating and restricting the amount of data returned to the user. These are things that you're going to discuss with your developer. This is not something that I can't do this. I can't help change a web application that's vulnerable. Then there are things to do for broken session management, sensitive data exposure, XML external entity attacks, broken access control, and each one of these is for the developer. This is stuff that you steal from the class and you use for your emails to your developers. And the developer's like, wow, I had no idea you knew so much about it. I mean, you are talking about identities and credentials that are stored in hash form. We don't do that, but wow, I didn't know you would even think about generating cryptographic keys online, or I didn't know that you knew anything about avoiding insecure IDs to pretend, all this stuff. XML unmarshallers. Have you ever used an XML unmarshaller? But I tell you what, if you're a developer, you develop web applications, you use XML unmarshallers. Right? And if you're going to do that, it really needs to be configured securely. This is something that you need to tell the developer. So my point in all this is this is not for me or for you. This is for me and you to use when we're dealing with a web application developer. Other things that we deal with our developer on are security mechanisms, making sure that we disable unused services, making sure that we have good roles and permissions, making sure that we scan the site for vulnerabilities. Scan the app for vulnerabilities. deal with SSL, validate headers and cookies and cross-site scripting issues, looking for those. And maybe even, this is something if you are one of the network engineers that you can assist your web developers with, maybe, but also it's something that on a software basis, web developers deal with all the time, and that is web application firewalls to block certain types of scripts and code execution, converting non-alphanumeric characters to HTML character entities before displaying user input in search engines. Wait a minute. Make sure you get that done, all right? Want to have that done by, a few minutes. No, this is something your developer is going to do. The programming people are going to do this. All right, other things to do, and again, for insecure deserialization, you have to check out your trust boundaries. In some cases, and this is not just for insecure deserialization, but there are several cases for web applications where in order to make the application secure, you have to tear down the app and completely re-architect it. And that's definitely the case if you have poorly implemented serialization. You need to regularly patch, regularly check for vulnerabilities, making sure that you have a SIM that exports all your logs and that they can be analyzed, and making sure that you're not being attacked. And there are tools that you can use to test your web application for security. NStalker is a web application security scanner. Acunetics. Oh, look at, there's Metasploit again, the all-around giant in the room toolbox to help you with every aspect of hacking. Powersploit, Watcher. That brings us to SQL injections. SQL is structured query language. It's the language that RDBMSs, Relational Database Management Systems, speak when they are moving data in and out and where they're being built, and it's just their language, structured query language. And so we're going to look at injection attacks using SQL. What is SQL injection? Well, we take that nice little structured query language and we tell the database at the back end of the application to do something. So for instance, let's say I have an application and there's a form that I need to fill out. And instead of filling out the form, I put in an instruction for the SQL server that creates a new account for me. Or I ask the SQL server to delete an entire table. Or I tell the SQL server to change the password or give me admin privileges or change the prices of all the stuff in this category to $1. These are the types of things, the types of attacks that can take place against a database server using SQL injection, allowing attackers to do all kinds of stuff like gain unauthorized access, get data information, buy things for $1, stuff like that. So why bother? Well, because if you don't care about SQL injection, it will allow attackers to bypass authentication. They will allow them to compromise data integrity, will allow them to bypass authorization and compromise data and have information given out without control and even do remote code execution. It's pretty bad. SQL injection attacks can do quite a lot. In some cases, it's shocking what you can do with a SQL injection attack. So what SQL injection attacks do is they attack server-side technologies. There are powerful technologies like ASP.NET on database servers. Developers use these powerful technologies to create these dynamic, data-driven websites and web apps that are easier than ever to create, but more dangerous than ever. And then with ASP.NET and SQL, hackers can exploit this with injection attacks. Which databases are susceptible to SQL injection attacks? The answer? Yes. All relational databases, all RDBMSs, relational database management system, relational databases, are vulnerable to SQL attacks like SQL Server from Microsoft, Oracle, IBM DB2 from IBM, MySQL open source, PostgreSQL, Also, there's a new trend of non-RDBMS databases like NoSQL based databases like MongoDB. Those can also be vulnerable to similar types of attacks. And so what they do is you send through the target web app into the database a command to do something, and the database responds. All right, so there are different types of SQL injection, blind, inferential, that take advantage of delays and Boolean expressions and super heavy queries that help to return information, break into that database. There are in and out of band injection. Some of the in-bands are error-based and union and tautologies. Tautology is one of my favorites. It's just like 1 equals 1. I'll tell you how that works in just a little while. End-of-line comments, in-line comments, piggyback queries, stored procedures that you can actually store in the database as part of an error-based injection. And you can even do illegal, illogical queries, whereas tautology is a legal query. I mean, not legal, but logical query, right? 1 always equals 1. X always equals X. But you can do a query with 1 equals 2, which is never true. And so it's illogical, and you can get, again, errors from the SQL server and use those to do further attacks. So SQL injection in-band is when you are using the same communication channel to perform the attack and retrieve the results. In other words, you're not using one channel to do the attack and then another channel get results. So like for instance, I can use a URL in a browser or a web form and get the results right back. Like for instance, we have error-based SQL injection, and with that, you put intentionally bad input causing the database to throw an error, and depending on the error you get back, you know what you can do further to attack that database. And so if you get a very verbose error, in fact, that can tell you that this is a very attackable database. But if you get a page that comes back and says an error has occurred and you don't get a specific error back, then it's going to take a little bit more work on that system. Also, we have illegal or logically incorrect queries like 1 equals 2. Again, what we want to do is intentionally generate errors so that we can find out more about that SQL server. Another one is stored procedures. Stored procedures are sort of code like scripts that come with a database, and they can be used to help automate that database. They're very nice to have around. They can be created by DBOs and DBAs. Database administrator can create one, but what they can be also used for is to exploit, be exploited by the attacker and do more attacks. That's why it's very important to get rid of any extra stored procedures that aren't being used. Another one is a union injection. And so you could take a normal SQL query like you see here, select name and address from users where ID equals 1, and then you can say, you know what? I think I want to do my own malicious query. And so you put the union keyword at the end of that query, and then you do a select credit card number from credit table, and boom, instead of just having name, address, and phone, you have a list of credit card numbers. It's completely doable. That's in-band SQL injection, in this case using union. Also with inbound SQL injection, probably one of the first areas that you'll be dealing with, especially if you go into iLabs and practice some of this. And in the real world, often one of the first things you'll try is a tautology. A tautology is something that is always correct. It's always true. 1 always equals 1. 2 plus 2 always equals 17. 4. So either way, where you have a tautology, here's what it does to the database. Often with a database, what we're looking for from the database is not a huge amount of information or a huge amount of data. We're looking for an answer. We're looking for either true or false. So for instance, let's say that I'm logging in to an application. And my username is Kevin, and my password is password. So in the case of a tautology, this is how normal versus a tautology works. Normal, I hit OK with my username and password, or hit enter, and then what happens is there's a query. Select star from users where username equals Kevin and password equals password, and then there's another select statement from the password table. So both the password table has to have a password for Kevin and the user table has to have a username for Kevin. If both of those return true, then the database returns true. If one of those returns false, then the database returns false. If the database returns false, then there'll be a new page that will say, I'm sorry, you had the wrong password, try again, or something like that. If the database returns true, then the web application will return a page that's customized for that user. So that's how it works. With a tautology, what I do is I type in username Kevin, and then for the password, I put some combination of 1 equals 1. And I put an OR there. So or in the username itself, without a password, I can put in tick, blah, tick, or 1 equals 1. And so it'll consider the blah. It'll say, I don't know what that is, but there's an OR here. I can look at this. Oh, 1 equals 1. That's true. And then all of a sudden it logs you in. Yeah, really. Actually, it's that simple in some cases to get into a login page using a tautology based upon what's actually happening with that SQL underneath everything. There are other things too that are helpful in hacking SQL servers. Those are inline comments. And so the attacker might use multiple vulnerable inputs, but use inline comments. Also, this helps sometimes to bypass web application servers because it just sees a bunch of comments, but in actuality, it's an attack. It's an insert into attack. Another one is the end of line comment. See this right here, this double dash? What this double dash means is I don't care what else was in the SQL statement, but ignore it. It's just a comment. In programming and databases, comments are ignored. And so you'll do your blah, tick, or 1 equal 1 in the username, but in the actual SQL command, it says and password equals password, right? But after the 1 equals 1, I put a dash dash, and that means that the part about the password, it's just a comment. So the true from 1 equal 1 applies, and nothing else does. Hey, what do you know? So that's what that end of line comment is. There's also piggyback queries. So here's a query, select star from employees, where employee ID equals 1001 and employee ID equals Bob. And then after that semicolon, I'm piggybacking a new query. Drop table department. And so the database says, all right, I found this whole Bob thing. Oh, all right, I deleted the table. Bye-bye. And the table has been dropped. So that is a piggyback query. One of the most successful and actually difficult in terms of iterations and so on, which is why we have tools to help out. One of the most successful and potentially difficult types of SQL server attacks are error-based SQL injection. In this case, what we want to do is force the database to do an operation until it's going to result in an error. I know that. But we iterate and iterate until it finally coughs up an answer in many cases. And so depending on the database management system, DBMS, that you're dealing with, you have different ways of doing this. So here's a query here, select star from product. So there's a table in the relational database management system. And if you've never dealt with RDBMSs, maybe some of this stuff is kind of surprising to you. Let me just give you a query that you can use in Google or DuckDuckGo to help you understand this a little bit better. So try this. Try RDBMS tables. RDBMS tables. If you hit enter and go to images, you'll see a list of tables, just sample tables, all right? if you do another query on another tab, you do RDBMS, Relational Database Management System, Table Relationships. And you do that one, and it'll show you samples of database tables that are related together by keys, primary keys and foreign keys. You can look at images and see how that works. And so you have a database. It has a huge number of tables. Some of them have usernames. Some of them have passwords. Some of them have account information. Some of them have product information. Some of them have all these different stuff, but they're all connected together so that you can search across them. So in this case, what we're doing is we're selecting everything from the products table where the product ID equals some product ID. So 7535, whatever it is. So you're selecting a product with a product ID, specific product ID. So now here's a request that executes the query above. So if you look at this URL, sample.com, product.pht, question mark. So this is a parameter, ID equals 10. This ID equal 10, it actually generates and uses this SQL query that you see here. So the following request to a script executes the query above. So this uses product ID 10 as the $ID underscore product, that variable. So now let's maliciousize it. Hey, I made up a new word for the day, maliciousization. All right, so now we have product ID question mark. And remember, it's after the question mark. We have the document is product.php. The location of the document is www.example.com. The protocol, it's HTTP. Question mark means that's the end of the document location. Now we're going to do parameters, and it's ID equal 10. See these two symbols here? They're the pipe symbols that we use, two of them. For an Oracle database, what we can do is a util in adder get host name, select user from dual, and what this is going to do in an Oracle database is get user information. So I'm adding into that query, and it'll potentially generate an error, but the error it generates may direct me further and deeper into the hack. Yet another really cool one I like is union. What union does is it joins a forged query to the original query. So I have like all the phone and name and all this. So select name, phone, address from what table? Table name is users, where ID equals $ID. So $ID is going to be the variable. And so now what I'm going to do is set $ID equal to 1. So in, like, for instance, a URL, there might be the document location, a question mark, and then we have $ID equals 1. So that's the ID I'm looking for. And then I type in the word union. Now that says, you know that query? Whatever is behind that query, I want to add to it. I want to do a select all credit card number from credit table. And I hit enter, and then a table appears, and one of the columns has all the credit card numbers. Cray. I tell you what, it's quite doable. And so the final query were to actually be read without just $ID equal 1, looks like this. Select name, phone address from users where ID equals 1, which we got from right there. Union, all, select credit card number, etc. from credit card table. So it joins the original query with the credit card, and boom! Credit card information displayed on the page. Poorly written database, but these types of hacks happen all the time. So they're also blind inferential SQL injection attacks. And with these types of attacks, you don't get a direct response from the SQL server. You don't get an error message, right? So you have an application and you try a specific type of attack, and they're not visible. The results of the return is not visible to the attacker. There's a generic page. So you have a normal SQL injection, but instead of a nice custom page with error information that you can read, you get a generic page, not useful. Another one is time sensitive. And in this type of attack, sorry, not time sensitive, but intensive, what happens is you use some type of methodology to create an attack that creates a new attack before the first one is recovered. And so you take advantage of timings. So you can still, if you look at this, note, an attacker can still steal data by asking a series of true-false questions through SQL statements. And that's what we're doing in the blind and inferential SQL. So for instance, I ask a true or a false statement, and one generic page takes a certain amount of time to appear, and the other one takes another amount of time to appear. I have my answer, depending on which one is the true and which one is false, depending on the amount of time it takes. So there are many ways to do this. It's actually very fascinating, the subject of blind and inferential SQL injection. So here is one of the methods. So here the attacker says, hey, SQL server, delete, in other words, drop the table orders. And what does that double dash mean? Do you remember that? That means that whatever SQL statement existed afterwards is now turned into a comment, so it's going to be ignored, all right? So this SQL injection works, and even though I get a generic page and it says, oops, we're unable to process your request, please try back later, actually it worked. If there wasn't a generic page, I would get a return back that indicated that there was a problem, an error, right? ODC error 8004E14. That would have informed me of the actions that actually took place. But in this case, I don't see anything, but the attack was actually successful. It was blind. I didn't see it be successful. Also, you can do a wait for delay. In this case, you don't have a error message returned for the command, the execution status. So what you do is like sleep. You specify amount of time to wait, and then you specify that time, and then you run a command. So in this case, we're running a command here. If it exists, select star from credit card, wait for delay 10. And so we check the database for credit card. If it's yes or if it's no, that delay helps us determine how long that response took, and it can give us information on whether that information actually exists. Is there a credit card table or not? So depending on how fast we get that response back of the oops, we can measure it and use it for further attacks. There's also Boolean exploitation. In this case, we're going to evaluate true falses over and over again. Boolean exploitation is one of the most successful types of exploitation, just by making multiple valid statements that evaluate to true and false for the parameter we're looking for in HTTP request. In other words, does the username start true or false? The username starts with an A. True or false? The username starts with a B. True or false? The username starts with, and you go on through it until you receive all the answers, and you can put together usernames and passwords and database names and stuff like that. So what you do is you compare the response page between the true and false conditions, and you can tell whether or not the injection was successful, kind of like we were talking about before. So here's a URL with an item ID of 67. You want to manipulate the request, and so what we're going to do is we're going to add in a Boolean, and 1 equals 2. That's going to evaluate to false. And so this query is going to be executed, and we're going to have that false evaluation, and then I can measure that false response and iterate over time to find the answers I'm looking for. Also, there's the idea of a heavy query. You can use heavy queries to help with time delay instead of using a timing function on your SQL attack. And so you can do those. It retrieves a huge amount of data, taking a long time to execute it on the database. And you can set up these heavy queries by using multiple joins on a SQL command, and then take up all that time, and from there, do measurements on the database to find out information. There's also out-of-band SQL injection. In-band means it's the same channel. I send the SQL injection through the web application, and my answer comes back through the web application. In this case, we're using other means to get the answer. So with an out-of-band, the attacker needs to communicate with the server by using the web application. So I go through the web application, get to the server, or I can use another communication channel for the attack results, like for instance, DNS and HTTP to get data from the database. So one band is DNS, the other band is the database. So the one band is HTTP, and the other band is the database. So it's out of band. So an example, you have an SQL server, Microsoft SQL server. The attacker exploits the xp_dir command in order to send DNS requests to a server controlled by the attacker. So we're using database stuff to control a DNS to get to a server. So we have a couple different bands going on there. That's why we call it, and we have out of band. All right, so there are tools. Now, I wish we had time to show you how some of this looks. Like, for instance, for some of the blind Boolean queries I was describing, where you can say if exists, database, a table, whatever, username begins with A, true or false, right? True or false, username begins with B. True or false, username begins with C. And you use these Booleans to generate true-false statements and find out eventually the username. Or you can use a regular expression. So find a pattern of a username or a password. And in order to do these things, you have to iterate over and over and over again, getting yes, no responses from the database that you can measure and use. But to find the database name, iterate through all the letters of the database name. To find the name of each table in the database, iterate through the names of the tables. To find the names of each column and each item and each column in each table, that can take you years working on a database. Fortunately, there is SQL Map to the rescue. SQL Map automates the process of detecting and exploiting SQL injection flaws. I've seen SQL Map in action. I've used it many, many times and watch it work through these Boolean iterations. It's just fascinating actually knowing what's going on in the background and how fast this tool is working through it to find my database, to find the tables, and to find the contents of the table I'm after. SQL Map, top rated, very cool. Mole, very nice tool. Blind SQL, bit shifting, no SQL Map. This is especially nice when you're dealing with non-RDBMS databases like NoSQL and SQL Power Injector. So there are tools to help you with this. You don't have to know every SQL statement. In fact, you don't even have to know much about SQL if you know how to use SQL Map. Now let's look at some countermeasures so you can avoid having your database attacked. So there are a few things. And again, I want to emphasize that a lot of what we're talking about here, you really need to have saved as a page that you'll use to talk to your developer, right? So you can ask the developer, hey, developer with the SQL database, are you making assumptions about the size and type of the content that's being received in the application? And the developer can say, actually, no, we used to have some limits to that, but actually now what we do is we're completely size agnostic. Oh yeah, very good. Are you testing the size of your data input and enforcing appropriate limits so we can avoid buffer overruns? And the developer will say, oh, actually, yes. In fact, let me show you some of the size tests that we have and what we're doing to protect against buffer overruns. They know all this stuff, and all you have to do is know what to ask. Although I really encourage every student in the class to take a chance, learn about databases. In fact, there's a very nice YouTube class, a couple of them I've seen before, that take you through MySQL. If you have almost any device, Windows, Linux, Mac, you can install MySQL as a server, a database server, and then you can go through a bit of a actually it's a 3-hour class, most of these, to learn how databases work. It's actually really worth it to actually know how databases work, to know what a string variable is versus other types of variables that deal with a floating point and so on, right? In string variables, they need to be tested because you need to make sure that it's just a string that has somebody's name in it, not an SQL command that's attacking the database, right? It's really good to know what an escape sequence is and what binary data is. But if not, just ask your dev if they're rejecting inquiries that contain this. Never build transact SQL statements directly from user input. Rather, have them already pre-built and implement multiple layers of validation through your app and through that SQL server. And try to make sure that your database is invulnerable to SQL injection attacks by using SQL injection tools like DSSS, which is an injection vulnerability scanner that helps you look for vulnerabilities. Why not try that on your database before an attacker does? Why not use tools like Burp Suite to test your web applications and the underlying SQL vulnerabilities before the web attacker does? Why not use HCL AppScan to test your web application and the underlying database before the attacker does? Find the vulnerabilities in your database. Find the vulnerabilities in your web app. Find the vulnerabilities in your web server, and don't allow them to become a method for attack by outside threat actors. So in this module, what we've seen is that we have so many different types of attacks that can occur in web servers, web applications, and in SQL servers. And there's a lot that we can do in terms of countermeasures to defend against these types of attacks. And so lots of stuff to think about. What I do suggest right now is that you spend some time in iLabs and practice doing some of the stuff that I'm going to show you there. That'll get you more used to the terminology, the methodologies, the tools that are used for these types of interactions. In the next module, we're going to look at wireless attacks and wireless countermeasures. So join me there.